start. So my name is Catarina. I represent TIPMerge, recommend expert for integrating changes across branches. So the use of branches is a common practice to manage collaborative software development. We have an example of that here in the Rails project, where 47 developers worked committed in one branch and 52 committed in the second branch. Normally, these developers are working in possible in the same files and same methods. At some moment, the merge of these branches may be necessary, and this process can be hard because the person in charge of this work must ensure that the result, the merge, correctly combining the parallel work, not only consider direct conflict, change the same parts of the file, but also indirect conflict, syntactic and semantic ones. As I said, it can be hard because it's not always clear which changes the person in charge must keep or reject, and sometimes the developer doesn't have enough knowledge to make the right decision. So we confirmed that in a survey with 164 developers, where people said that frequently they made decisions with which they were not comfortable, and also contact other developers to resolve the conflict together. With this in mind, our research program is recommending developers to merge complex branches, and we checked the literature to see what people are doing related to our problem, and we found that people are recommending developers for contribution evaluation, pull request using different techniques. But this is a merge of branches. But in these branches, we have just one developer in one of the branches. Normally contain few commits performed by just one developer, and is more like a workspace merge, just a easy reintegration of the forked branch. So we propose TIPMerge to identify the most appropriate developers to merge branches, and our approach has the following steps. The first step is the data extraction, where TIPMerge extracts the information from our repository. Then we identify the developer that changing key files that are potential generator of conflict, direct and indirect conflict. Then we check parallel change and dependencies. And then with all this information, the key files and who altered these key files, TIPMerge is able to generate a ranking of suitable candidates to perform the merge based on a medal count system. So I will talk a little about each of these steps. The data extraction, as I said, we extract the information from the repository, and first of all, the user needs to inform which are the commits that will be merged. In this case, C57, C58, and with this information, TIPMerge identify who is the common access of these two commits, and is able to check the information from the two branches. In this case, in a hypothetical project calculator, feature branch and master branch. And with this information, you can check who the files that were changed in these branches, and who altered this file, and who altered the previous history. In the second step, we need to identify the key files and who altered these key files. We have two concepts for key files. The first is files changed in both branches, because if one file was changed in both branches in the same parts, it can generate direct conflict. And in using our example, our calculator project, you can see that quadratic equation and subtraction were changed in both branches. In the master branch by Alice and in the feature branch by Bob. So you can add these two files to our key file list. The second concept is files changed in one branch with dependency in another branch. This dependence, we calculated this dependence, the concept is logical dependence, files that were changed many times together in the history of the project. So we used the previous history to calculate this dependence, and we believe that if two files were changed together many times in the history, and now they are changed in different branches, it can generate indirect conflicts. So using the history of the project calculator, we can see that I equation was changed in 12 times and quadratic equation was changed together in 8 times with I equation. So considering a threshold of 0.6, we found that quadratic equation depends on I equation. Both files, quadratic equation and I equation, are key files for us, for our approach. But as quadratic equation is already in our key file list, we just need to add the I equation in our key file list. It's important to mention that we had 5 files in this project that were changed in the branch, but just 3 files are potential generator of conflict, direct and indirect conflict, and are important to our approach. The last step of our approach, the developer recommendation, we applied an algorithm with all the information that we got from the key files and who performed the changes. We applied an algorithm that counts each contribution and creates a ranking of suitable candidates. Our ranking is analogous to how countries are ranked in the Olympic Games. So we have 3 medals for contribution in key files. The first medal is the gold medal. We have 2 representation, and it represents the changes in key files in the branch. So branch 1, branch 2, or in the 2 branches. The second medal is the silver medal for changes in key files in the history. So we have just 1 representation of the changes in the history. And finally, the third medal is the bronze medal. This medal, a developer can receive a bronze medal if he changes a file that depends on another file in a different branch. We have 3 representations for this medal that represent the direction of the dependence. And we believe that if someone changes a file that depends on another file, it means that he probably knows a little about the other file, and it's a user's knowledge. So we use the project calculator to see each key file and who changed it and who will receive the medals. The first key file is quadratic equation. You can see that just Bob and Alice changed these files in the branch, then they receive a gold medal, and Alice, Anna, and Alex changed in the history, and they receive a silver medal. The second file, key file subtraction. Bob and Alice changed these files in the branches again, and Bob and Alex changed in the history. Finally, I equation was changed just by Tom in the branches, and the history by Tom, Anna, and Alex. So we have the gold medals and the silver medals. As I said before, quadratic equation depends on I equation, and the person that changed the quadratic equation will receive a bronze medal because he or she probably knows something about the file I equation. So Alice will receive a bronze medal. With this information, can apply our average that counts the number of gold, silver, and bronze medals, and we can rank the 5 developers that are suitable candidates to perform the merge. TIPMerge was implemented in Java and is able to check any project, in any Git project, in any programming language. And so this is the main window of TIPMerge. The user can select a project and see general information of this project. And we have the ranking window with the same information that I showed before, Alice, Bob, Tom, Alex, and Anna. The information about the file that they changed, the number of medals, and we have information tooltip about the dependency. Alice didn't change her equation, but she changed whatever equation that depends on her equation because that she receives a bronze medal. So to verify the TIPMerge recommendation, we performed 2 evaluations, the quantitative evaluation and a quantitative evaluation and a qualitative evaluation. In the first evaluation, we checked 28 software projects, and in the second evaluation, we checked 2 projects. We interviewed 3 developers from 2 projects, status and diploma. So, in the quantitative evaluation, we first randomly selected 28 projects. Then we checked project merge case where key files were changed, more than 15,000 merges. And then we checked the top 3 guys that performed most of the merge in each project. And then we checked who actually performed the merge in the history of the project, and we check this information, compare this information with our TIPMerge ranking, and we check if this guy that did the merge was in the first, second, third, or other position of our ranking. With this information, the majority class, the guys that performed most of the merge, and our ranking information, we check the normalized improvement accuracy of TIPMerge accuracy over the majority class accuracy. What is that? Normalized improvement is, for example, if I have the majority class of a project in 80%, the top 3 guys performed 80% of the merges, and we have a space of improvement of 20%. If TIPMerge was 90%, we recommended in the 3 first position in 90% of the merges, the improvement was 10%, but as our space was 20%, the normalized improvement is 50%. Use the majority class, the top 3 developers that performed most of the merge to classify the projects, the results, and in 3 categories. The first category is top clear integrator. 7 projects are in this category, and in this category, the majority class, the top 3 guys, is less than 50%. The category 2 is the integration team is 18 projects. In this case, there are more than 50% in top 3, but in top 1, less than 50%. And the last category is the integrator, only 3 projects, and the majority class, the top 1, is more or equal 50%. Our focus, our approach focus is in these 2 categories because in the first category, we believe that anyone can perform the merge because there is no clear integrator. And in category 2, we have a small team of integrators, but we believe you can help in this situation because it's a small team of integrator. And in the last category, there is an integrator, a guy that performs most of the merges, but you can help in a collaborative merge session, assigning someone to help the integrator. The results show that TIPMerge had a normalized improvement compared with the majority class in 6 of the 7 cases in category 1. And the best result was Lantern with almost 80% of improvement. Category 2, we had improvement in 17 cases of 18, and the best improvement was also almost 80% of the normalized improvement in Eureka project. The last category, just 3 projects, we didn't expect a lot of this category, but we got a good result in diploma project, more than 80% of improvement. And for example, Maven, the 3 guys that performed most of the merge performed all the complex merge in this project. The second evaluation, the qualitative evaluation, we interviewed 2 developers from Sapos, from a total of 10 developers, and Diploma 1 developer from a total of 5 developers. And we select some merge cases where we recommended the guy that did the merge in the 3rd position. This is the TIPMerge recommendation, the 3rd position, in the 2nd position, and in one case in the 1st position. And we check if our recommendation was good or not. We found that factors like collaborative practices and collaborative software sessions, perform the most recent changes. For example, the guy that did the last commit, and knowledge about specific parts of the code base had an effect on who was responsible for the merging task. So we presented an approach and a tool that try to recommend the most suitable developers to perform the merge of branch, the complex merge of branches. And you saw that in our 28 projects that we analyzed, we had an improvement in 24 projects. So the results were good, and we plan for future work, do the same analysis at a method level, and then help the decision of choose more than one developer in a collaborative section, introduce the concept of joint expertise coverage. We would like to thank some developers and institutions that helped us, and